In this video, we're going to describe the difference between pure, fresh and potable water, and then explain the treatment process for both fresh water and seawater. Potable water is water which is safe for humans to drink. It's the water you'll drink if you buy a bottle of water or you get water from a tap. It will contain dissolved substances in it, and these are commonly salts and minerals. It is not pure water, which we'll look at in a moment. It has a pH which is close to neutral, about in the range 6.5 to 8.5. And it has no dangerous bacteria or microbes in it. Pure water, however, will only contain water molecules, nothing else. You might sometimes hear this called distilled water. It will have a pH of exactly 7, and it will boil at 100 degrees. This is a way we can test whether water is pure or not. If you had water from a tap, we've already said it's got some dissolved minerals or salts in, so it wouldn't have a boiling point of exactly 100 degrees. Because it's an impure substance, it's an impure solution, it would have a boiling point of slightly over 100 degrees, 100.5 degrees maybe. So in order to test whether water is pure or not, you would see if it boils at exactly 100 degrees. If it does, it's pure water. If it doesn't, it's likely to be impure. We can collect rainwater as surface water, so from lakes, rivers, or reservoirs. We can also collect it as groundwater, and that's where rocks trap that water underground. However, that water isn't safe to drink. We need to treat it first before we can drink it. The first stage in this treatment process is filtration. This is where we use a wire mesh to screen out any large solid objects. And then we pour that water over a bed of sand or gravel, and that will filter out any of the smaller solids. So after this process, there should be no solid particles left in the water. The next step is to sterilise the water. And this will kill any harmful bacteria or microbes still in the water. We can do this by either bubbling chlorine gas through the water or shining UV light on it. Both of these methods will kill any of the harmful bacteria or microbes. In some very hot countries, they don't have enough surface or groundwater. It's too hot for the water to stay on the surface, and there isn't enough groundwater underneath to use as drinking water. This means they need to use seawater instead. Seawater is really salty, you can't drink it, so we have to use a process called desalination instead, and this means removing the salts from the water. There are two methods we can use to desalinate seawater. We can use distillation, or we can use reverse osmosis. We're going to look at these two processes in a little bit more detail now. In distillation, the water is first evaporated, and that will leave the salt behind. Now, this will be done on a big industrial scale. However, I've shown a diagram of some lab equipment to put this in context. So the first step you would do is heat your mixture of salty water. This would cause the water in the mixture to evaporate, and would then move down this piece of equipment called a condenser. So the water would rise up and evaporate, and all the salt would be left behind in here. As the water vapour then moves down the condenser, it will be condensed, it will turn from a gas back into a liquid, and we can collect it as the end as pure water. And that's because around this distillation apparatus there is some cold water, which lowers the temperature of the vapour, condensing it back into a liquid. Now again, this will be done slightly differently on an industrial scale, but the process is the same. The water is heated up till it evaporates, leaving the salt behind. The water vapour is then cooled so it condenses from a gas into a liquid, and it can then be collected. We can also use reverse osmosis, and this is essentially where we put the water in a container with a partially permeable membrane, apply some pressure, and it enables the water molecules to fit through, but not the salt molecules. So if we have a look at our apparatus, we've got our mixture of salty water in here. We would apply some external pressure. This would force the water molecules through the membrane. The water molecules can fit through the membrane, but the salt molecules can't, leaving pure water on the other side of the membrane. So in summary, the salty water is pushed through a membrane which only allows water molecules through. The holes are too small for the salt molecules to fit through. This means the salt's trapped on the other side, leaving us with pure water. Both desalination methods, so using distillation and reverse osmosis, will require a lot of energy to make them work. The distillation requires a lot of energy because it has to be heated up, and the reverse osmosis requires energy because we've got to force the water through, we've got to apply pressure. Where processes require a lot of energy, this makes them very expensive. And this means that we only use these options when there is no other way of getting that water available to us. So this is why even when countries are surrounded by the sea, if they've got freshwater sources, they'll always choose to use the freshwater sources rather than trying to desalinate the seawater, because it's much cheaper, because it doesn't require as much energy to treat fresh water as it does to desalinate seawater.